Hi everyone, hope all are doing good. Today's session we shall discuss what do you mean by factor of safety, lateral strain, Poisson's ratio, and volumetric strain, relation between modulus of elasticity, rigidity, and Poisson's ratio, and relation between Young's modulus, bulk modulus, and Poisson ratio, and relation between Young's modulus, bulk modulus, and modulus of rigidity. So first we shall go with what do you mean by factor of safety. Factor of safety is generally defined as the ratio of ultimate stress to the working stress. In general words, factor of safety is nothing but with respect to the factor the above the material can be withstand is nothing but the factor of safety. Then what do you mean by ultimate stress and working stress? In the last class we discussed about stress strain diagram for mild scale. Up to one particular point it will be having cracks. After crossing one particular point, that point is nothing but ultimate point. There it really causes of fracture. That is called as ultimate. And next, working stress is defined as the maximum allowable stresses to which the material subject practically, which means up to what stress it can be allowed is nothing but the working stress. And these will be always lower than the ultimate stress. And next we shall go with what we mean by lateral strain. Whenever a body is subjected to deformation other than length, okay, which means height or thickness. So the change of with respect to original width is also called as a lateral strain. In general words, in technically it will say is as deformation of the body in the direction right angle to the applied load. Okay. So this is regarding lateral strain. Now what do you mean by Poisson's ratio? Poisson's ratio is defined as the ratio of lateral strain by linear strain or longitudinal strain, and it is denoted by mu or 1 by m. Okay. And next is volumetric strain. It is defined as the ratio of change in volume to the original volume. For rectangular bar, the change in volume is nothing but change in length by original length plus change in diameter by original diameter plus change in width by original width. For cylindrical, it will be change in length plus 2 times of change in diameter by original diameter. For sphere, it is 3 times of change in diameter by diameter. Okay, hope everyone clear. So now we shall go with the relations with what is the relation between Young's modulus, modulus of rigidity, and Poisson's ratio. We know that modulus of elasticity is nothing but is a ratio of normal stress to normal strain, and modulus of rigidity is defined as the ratio of shear stress to the shear strain. Okay, so now let us take a block of like this rectangular plate and having the material's elastic constants Eg and Poisson's ratio mu. Whenever this cube is subjected to a load, okay, then there will be complementarily shear stress will be acting. So now assuming a small angle of strain is applied, and this will be reflected as ACB. Therefore, the change in length is this O to the A, and this OA and OB are having very small. So now considering only the diagonal 0 to A. So OA can be taken as with respect to triangle OAC. So it is BC by this BC by OA. Okay. So AC, BC is nothing but AC cos 45. So OA is equal to A by sin 45, that is A root 2. So strain is change in length by original length. So AC by 2A. So where gamma is shear strain, thus the strain and the diagonal is gamma by 2. We know that modulus of rigidity is nothing but shear stress by shear strain. So now I can take gamma is equal to shear stress by modulus of rigidity. Now with respect to diagonal, it is comes under linear. So with respect to volumetric strain, sigma 1 by E minus mu into sigma 2 by E. So sigma 1 we got it as tau by E minus mu into minus tau by E. So tau by E into 1 plus mu. Now correlating these two relations, so E is equal to 2G into 1 plus mu. Similarly, with respect to E, K and U, so now let us consider a cube, okay, with sides A, and the volumetric strain is sigma by E minus, in x direction it is sigma by E, y with respect to Poisson's ratio. So E into sigma by E. So sigma by E into 1 minus 2y. Okay. Volumetric strain is 3 times of linear strain per cylinder. So volumetric strain is equal to Ex plus Ey plus Ez. And as it is similar shape area cross section, Ex is equal to Ey equal to Ez. So 3 by sigma E into 1 minus 2 gamma. Bulk modulus of velocity is nothing but volumetric stress by volumetric strain. So sigma by k is equal to 3 into sigma by E into 1 minus 2 gamma. So E is equal to 3k into 1 minus 2 gamma. Okay, I hope everyone is clear. So now what is the relation between E, G, K and K? So we know that E is equal to 2G into 1 plus mu and E is equal to 3k into 1 minus mu. So now you substitute this equation. On simplifying the LCM, we will take it as 9gk by 3k plus g. So this is the relation between Young's modulus, modulus of rigidity, and bulk modulus. So with this, some sample short answer questions are: define Poisson's ratio, lateral strain, working stress. Most importantly in examinations, we may ask to solve or derive the relation between EGK or EG mu or EG EK